Hey everybody, this is the kgateway community meeting. We have two things on the agenda today. I'm very excited that we're going to talk about release cadence first, part 2. So Nathan, I think you are leading that topic. Do you need screen sharing?
No, thank you though. We haven't really seen that much sort of new content around this, but we added this last week as a placeholder to sort of say, if I'm interested in using kgateway, how do I know when something sort of goes out? There's been some good strides towards defining our next step, but nothing sort of outside of just some like milestone development and everything that was done last week by Damien. Thanks again for doing that, by the way. Obviously we'll have to refine more in the future, but it seems like people don't have strong opinions at this time, so we don't necessarily need to force it if people don't have anything to push. At least that's my stance, and this is one person saying things as so happy to hear others thoughts on this, and obviously it doesn't need to be locked in stone. If people are listening to this recording and have opinions, please raise them.
All right, very good. I'm going to pull out the milestone link Daniel added. I think that's very useful. Somebody else wants to join. Let me unmute. All right. So from the milestone, thank you, Craig, for joining. We'll just get started. I guess we can easily click, what are the key items for which releases? Is that the idea? So the next one is
but also to give some confidence in the timeline, right? So previously on this community meeting, one of the things that was raised is like we probably minimally want to be aligned to within some boundary with Envoy's release cycle, given that this depends on Envoy, but there's other factors. So like there's some people who might want to move faster on some of the early spaces as we continue to add in some like large features. Like right now there's some pretty big changes to delegation going on, and someone might argue that those constitute a need for a quicker minor version than this timeline says. So don't know of any other pressures that are pushing that. So that's sort of the context, at least from what we talked about last week. And anyone who's here or listens to the recording who remember something better than my imperfect way on this can sort of chime in. But yeah, we're just trying to figure out. I think it'd be good for us to at least talk a bit more at some point around releases. So if anyone on the call has opinions, it's a great time. Otherwise, we'll punt.
Yeah, does anyone else wants to weigh in on this topic? All right, if not, let's jump to...
Oh, sorry.
Go ahead. No. Go ahead.
I just wanted to see if you guys think that we should also like tag the docs like in the same milestone, or just keep tracking them in the separate doc repo like we did for the initial release.
Is it possible to tag it here? Given
I think we might have to create the issues in there. I'm not positive, but
that's what I'm worried. The extra work for you of the team.
Okay. Yeah. I mean, I'm fine either way. I've just been like creating new issues in the doc repo just because that's where we were using before. So
yeah,
just wanted to bring that up.
Makes sense. So whatever is working for you, and I trust your judgment on that.
Okay. Yeah. Sounds good. Thanks.
Yeah. Okay, let's jump into the next topic. kgateway AI inference extension. Craig, I saw you just joined. First of all, welcome to the community meeting. And do you want to give us a quick intro? Or,
Hello. So I just started using kgateway because actually I was trying to learn Gateway API, and kgateway showed up in the web search. So I just started using it. The tutorials you have on Gateway are very, very good. So thank you for the very good tutorials. And I just started asking some questions in the Slack channel, and the help I got was very helpful. So I saw that today on the agenda was a topic about inference extension.
yes.
So that's why I joined the meeting, because that sounded like a very interesting topic. So I'm just interested in learning, and I didn't want to distract the meeting. So I just wanted to thank everyone for the good documentation, the good help, and I'm looking forward to learn about the inference extension.
Okay, amazing. Thank you for the quick intro. Appreciate that. I'm going to pass mic to Daniel, who's going to, give us a little bit of education on inference extension and the latest update. I think that's what everybody is here for. So, Daniel, take it away.
Yeah, let me let's
I'll
see.
stop
Lynn is
there.
presenting. They present now. Let me just share my entire screen here. Everyone see my my screen and the Gateway API inference extension slide here? Cool. So I'm going to run through just a couple slides to set the stage. Actually have an environment set up with inference extension and testing and all that good stuff where we could take a look at things. We'll just kind of see how things go here. But to start the conversation off, it's very simple, right? Generative AI is not a web application. Kubernetes was built initially to support web applications, added stateful applications with stateful sets. The behavior of generative AI applications, they behave very differently than web applications. And if we'd like to talk about those differences in more detail, we can. I have hidden a slide, but since we have a short amount of time, just want to put that out there. And that becomes the foundation for why the inference extension project started. The full name, Gateway API Inference Extension, right? It's a way to extend Gateway API to support inference-specific traffic, because, like I said, inference traffic is very different than our standard web app traffic, and we want the project to be extensible in many different ways, from what model server frameworks or engines are supported, like VLM or Triton, to which gateways are supported, like kgateway and others out there in the community. And these are kind of the top level goals of the project. And how do we reach those goals, right? So the areas that the project is focused on is providing APIs for routing inference traffic to workloads, inference-specific workloads. We'll cover those APIs in a little more detail. And then ensuring that that if it's a model server that claims to support inference extension, or if it's a gateway implementation like kgateway purports to support inference extension, that there's actually conformance tests to ensure that the implementations do support the APIs and protocols that are defined by the project. And although the conformance tests aren't there right now, there is work that's occurring in this area, and so I expect here over the next few months that we'll see the conformance tests, and then shortly after that, we're going to start seeing kgateway and others that support inference extension will also have conformance tests that pass and posted, and all those details are being worked out right now. And you know, this is following patterns that are already established, right, with Gateway API. Gateway API conformance was based off of ingress conformance, so you know, essentially following those same established patterns that exist with other projects before. Let's take a look at the API structure. So one of the attributes of Gateway API that I believe helped achieve its success is that when the APIs were designed, they were designed with the idea of multiple personas, right? And so when Gateway API went from, okay, prior to Gateway API, we had ingress and it was a single resource, and that's just not the reality of how you know, how resources are managed, especially when it comes to providing external access to you know, to workloads running in the cluster. There's security operations, there's cluster operators, and then you've got you know, developers that are managing their stack, right? And Gateway API was designed around those different personas, as you can see here. And Inference Extension Project essentially follows that same practice, right? And so in the inference world, you've got inference platform owners that are responsible for the resources necessary to run you know, the model servers, and then you've got your inference workload owners that are typically managing what engine they want to use to run the model, tuning parameters, and such. So let's walk through, you know, a typical request, right? Request comes in. Here's you know, the V1 chat completions API request. It's kgateway, and typically without inference extension, kgateway could look up paths, headers, and make a routing decision. You know, the secret sauce here with inference extension is this endpoint picker extension, which is a reference implementation of the inference pool API, right? And so this reference implementation, as its name states, endpoint picker, it's responsible for picking an endpoint based on a set of endpoints, right? And deciding when this request comes in, which backend model server should kgateway forward the request to. Well, how does the endpoint picker decide which is the best model, right? Instead of using typical HTTP attributes like headers or path, what the endpoint picker is actually doing is actively scraping these model servers, right? So scraping the model servers to see how much of the queue is being used, how much of the KV cache is being used, utilization of LoRa adapters if LoRa adapters are being used. So a lot of you know, Gen AI inference aware information that's being pulled to decide, okay, what's the utilization of these model servers, and then forwarding to what the best model server is within the pool to service the request. And when it makes that selection, it then passes it back to kgateway and says, hey, kgateway, forward the request to this IP endpoint. And so within the inference extension project, the two primary resources, or the two resources that are defined, is the inference pool and the inference model. And as you saw a few slides ago where I showed you the personas, inference pool is going to be your inference platform admin that's going to pull together all the back-end model servers that are similar, right? Similar meaning what accelerators they may have, what serving engines they may be running. So if it's you know, like a a pool of H100 accelerators and running VLM. That could be a pool that we put together along with which model server is running on those pool of pods. You see here the extension ref. So this is the mechanism by which the gateway, like kgateway, can find out how to communicate with that endpoint picker. Right. So in a few slides ago, when I showed you the endpoint picker, that is actually a service that's running in the cluster that the gateway communicates with. And so this is how the gateway discovers how to communicate with the endpoint picker. In the inference model, again, this is going to be your workload owner that's able to define what the model name is, criticality. I may have a higher criticality band for my model services for chat over model services that are doing summarization that don't have the same type of criticality or time sensitivity that a user interacting with a chatbot would. And then, of course, the pool ref, right? What pool is this model associated with? And then these target models, right? So this allows us to go ahead and do A/B testing of our models, do weighted round robin, and essentially also supports LoRa adapters so that if we have a request coming in for a particular model, we may have LoRa adapters for fine-tuning the model, and this allows us to basically load balance across those LoRa adapters. So with that said, we can take a look at my environment here. Actually, hold on really quick. Where are we at here? Did I put in the chat window? No, it looks like I didn't. Here, let me just give me a second here and let me do this. Let me. So here's a markdown on how I created this cluster, just using EKS Cuddle to create an accelerated cluster, and then just followed the quick start guide here. And so the guides we put together, if you see here, we added the kgateway documentation upstream. And so what you're looking at when I go here to my terminal is those two links that I sent, right? So I used EKS Cuddle to create a 3-node accelerated cluster. And then I went through the quick start guide to go ahead and deploy my model servers, the GPU-based model servers. And if you don't have a Hugging Face a secret already, you'll have to go to Hugging Face, set up an account, create your secret, and then you need to go to the model server that's being used, which is the Llama 3.1 8B instruct, right? So when you go here, you need to make sure that you sign the license agreement to have access to the model, and usually that license agreement gets accepted within a matter of an hour or two. But when you go ahead and you have your Hugging Face secret, and you export that as an environment variable, and you have access to the Llama 3.1 8B instruct model, you're ready to rock and roll. And so you create a secret for that Hugging Face token, and then you deploy your model server here. Pretty straightforward. You then the inference extension piece of the install is that you're setting up your inference extension endpoint picker. Or I'm sorry, excuse me, this is actually installing the CRD. So adding the inference pool and inference model to your cluster, then deploying the inference model, an instance of the inference model resource, an instance of the inference pool resource, as well as the endpoint picker extension, right? And then we get into the gateway piece, and we see kgateway steps here. But before we go into that, let me just kind of show you what we're talking about here. So we can get CRDs. I can hide this really quick. Oh, yeah. CRDs, and so you see the inference model and inference pool CRDs have been added to my cluster. Get inference pools. Here's my inference pool for my VLM Llama 3 8B instruct pool of model servers. And let's just take a look at it here in a little more detail, right? So I shared with you in the slides like this extension ref, right? So again, this is the way that kgateway discovers how to communicate with the endpoint picker. And again, that endpoint picker is a pod that runs, right, in my cluster. Here it is. Let's see, where is it? Here it is. Here's the endpoint picker, right? It's actually deployed as a deployment. So here's the endpoint picker. Right, and when I'm making this reference here, right, we say that it's a kind service. So kgateway is able to go ahead and say, okay, here's the service you told me about in the inference pool. Let me use this IP to communicate with the endpoint picker. So when traffic comes in, hits the gateway. So let's just kind of walk you through this. Right. So when traffic comes in, if I make a request to, this address, it's going to hit the inference gateway that is managed by kgateway, right? And then HTTP route, and then there's an HTTP route here that tells that gateway, hey, when you see a path match of the root path, right, a real simple HTTP route. But when you see a path match to root or anything, any subpath of the root, go ahead and use this inference pool to forward the traffic to, right? And so what does that mean from like a kind of a gateway implementation, right? Kgateway is going out and watching inference pools and then finding all the pods that make up that inference pool, and getting the endpoints for that pool. But again, kgateway is not forwarding, making the decision to forward to the endpoints within that pool. What kgateway is instead doing is saying, hey, when I go ahead and I receive traffic on my gateway address, right, and for this path, instead of forwarding to any of those endpoints, I'm actually going to go ahead and forward it to the endpoint picker, right, because I'm going to forward it here and have the endpoint picker tell me which endpoint to select from that group of endpoints, because the endpoint picker has the most knowledge about those model servers to make the most intelligent routing decision. All right. Let's see here. So, again, I've gone through this already. Kgateway's up and running. Deploy-m. Here's kgateway. It's up and running. I've installed the kgateway CRDs, deployed. We already saw the gateway that I deployed and the HTTP route that I deployed. Get HTTP route again. And what's key when you're walking through this yourself, just going back, looking at the status conditions, making sure that the HTTP route is accepted. As it states today, you'll see if you go to inference pools, you see there's no status for the inference pool. So that's going to be coming here in an upcoming release of kgateway, so that you'll actually see status being surfaced on the inference pool as well. But then you can actually try it out, right? Sending a request. So Echo, let's see if I have this already set up. Nope. Let me go ahead and do this. Right, so I'm getting the address of the inference gateway, setting it as an environment variable. We see it there, and then I'm going to go ahead and hit the inference gateway on its IP and port using that /v1 completions endpoint, right? And so we're going to send a simple request to the food review model with a prompt saying, write as if you're a critic San Francisco, and setting the max tokens for the request. So let's take a look here. We're going to get a response from one of our model servers. So really quickly here. All right, so when that request came in, it hit the inference gateway. The inference gateway, based on its HTTP route, went ahead and forwarded the request to the endpoint picker. Endpoint picker made a decision between these three instances of my model servers, right? So I've got three different pods running the model server, and the endpoint picker, based on scraping the metrics of these three model servers, like the inference specific and Gen AI specific inference metrics, decided on which of these three model servers to forward that request to, and then the model server responded, and this is the response that we saw. Let's see here. Logs. Let's see here. So let's just take a look at the logs. We'll do it one more time. Look at the logs. So this is the logs of the inference gateway. Here's the logs. Let's see, can you get to play? Okay, logs of the endpoint picker. Deploy. Right, and then here is logs. Okay, hit appeal. So I believe this is a model server that the endpoint picker has been selecting among the three. So let's do a logs PO. And look, one of the things you're seeing here is the endpoint picker is just continuously scraping the metrics of these model servers to always have, a near real-time view of what is going on with these model servers to make the intelligent routing decision, right? So here's one of the model servers that we're taking a look at the logs again. Here is the endpoint picker, and then here is the gateway. And let's go ahead and send another request here. And we should see, look, here's the endpoint picker logs. We saw, why did that request, I'm not seeing that here. But let's look at the endpoint picker logs, right? So we see that the request came in, the scheduler, right? So let me take one step back. We see that there's three pods that the endpoint picker is aware of, right? The three model servers that make up our inference pool that this endpoint picker is servicing. See the requests come in, get scheduled, right? It's selecting a pod from the three, and it has picked one candidate, saying that it's handled the request, and then it generated the response, right? And if we went back through here, we could probably see it. Let's maybe I'll generate it again. All right. I got to probably tune down the logs on this to actually see the request coming through, or I'm just not on there. Let's see here. What's so for review to do endpoint 24.25. Yep. So this is 24.20.24.25. It's just probably just not seeing it here. Let's try it again. There we go. So we see that this is the viewpoint from the model server, that it received the request. It scheduled processing the request and posted the 200 OK that it has completed the responding to the request. Yeah, you can go through the cleanup and whatnot. And there's some other things you could do too, right? So adapter rollout. So take some time and first understand LoRa adapters, or if you're already familiar with it, you'll see how this kind of add-on capability to inference extension for managing LoRa adapters can be used, and being able to load share between different LoRa adapters based on weights that you apply for the target models here, and pulling metrics. So if you want to pull metrics from the endpoint picker, this provides a quick rundown of what metrics are exposed, the type of metrics, or if you want to implement inference extension, you can follow the implementation guide as well.
This is great. Thank you so much for the live demo. I didn't expect it. Awesome. I saw a couple of hands. Ian, did you have a hand? Are you good? And I know Nathan, you had a hand too. So if you guys want to ask a question, now it's a good time. I also have a hand up, but I'll go after you.
Yeah, I was just curious. In your slides, you had a fail open on the inference pool. And in the actual demo, you had it set to failed close. When it fails open, will kgateway just make some sort of like pseudo-random decision about which model server to use, or what's going to happen there?
Yeah, so I mentioned status not being supported, so the fail type is also not supported at this time. And there is some work that's happening upstream in Envoy that, let me see if I have this, because this is going to help guide the conversation as well. Give me 1 second, because it is good to have this. Hold on. Yeah, I got it now. Here, just paste it in. And so there is some work that's happening upstream in Envoy to make this fail open, fail close, real, to be honest, right? So, one way to accomplish fail open and fail closed is doing subsetting within Envoy. It's kind of like a workaround hacky type of approach, whereas this pull request upstream in Envoy that I'm sharing with you is going to make the fallback load balancing policy real. And so what that means in a fail open situation, if the gateway like kgateway cannot talk to the endpoint picker for some reason, in a fail open situation, it's to say, hey, what is this fail policy that I'm, as Envoy that I'm configured for? If it's fail open, then go ahead and route based on, endpoint discovery, for example.
So then is the current behavior just basically fail closed style? If it can't talk to endpoint picker, the request is not going to go through?
Yes.
All right.
Which
Thank
is
you.
a safer way, I guess, for now. Yeah. Nathan, you want to go next?
Yeah, this is probably too in the weeds, so feel free to pass. We can talk about it at a different time. But I sort of wanted to understand with any of these extensions, and this is going to be very kgateway specific because kgateway is definitely an Envoy-based solution. So there's this concept of traffic mirroring. How does that show for any of these like basically like endpoint pickers? Like, can we push that decision? So the inference extension has given you information as to which endpoint to route to within a cluster. Is that also communicated over on that mirrored policy? Do we know? / would we even want it to be? I guess is the other question, because if it had to, like, depending on where you put your shadowing or mirroring, I could see it like making a different decision on the mirrored space.
Yeah. So, an inference pool. Think of an inference pool as a service, right? So when we think of gateway API and like the layers or process that a request comes through, kind of that last step is like, okay, now after any filtering has been done or whatever policies have been applied to the request, right? Now we actually need to forward the request to some endpoint, right? And typically that, like I said, that would be a service. And so the gateway API implementations as a whole typically say, okay, let me find all the endpoints that make up that service and then route to one of these endpoints, right? And now the difference with inference extension is we're saying, hey, instead of using a service, you're gonna use an inference pool. So like back to your question is that if you're doing mirroring, right, you're gonna do that as kind of like a policy, for example, or a filter that you would apply to the request higher up that order, right? And so you could very easily have two different inference pools. What does that mean? For each inference pool in the inference extension world today, an inference pool is associated to an endpoint picker. That may change in the future, but today that's the way it is, right? So whenever you think of an inference pool, you think of an endpoint picker. And so to your use case where we say, okay, request comes in, I mirror the request, right? And what do I want to do? I wouldn't think we're going to mirror it to the same inference pools, right? We're probably going to say, okay, let's have two different inference pools, A and B, and we're going to mirror that request. So now we essentially have two copies of it. And then we're going to go ahead and forward it to inference pool A and B, which would be processed by endpoint picker A and B.
So basically, it takes effect at the same time as like a load balancing policy or things like all the things are like once you've gone to your cluster and you need to decide exactly which endpoint to pick, any of those sort of policies, inferences at the same sort of time as any of those things, whether it be load balance or sticky session or all those things. So it behave the same way, at least in our current implementation, as those would, at least for this Envoy-based approach, which once again, I know is outside of the scope of the actual inference extension itself, but okay, no, that's really helpful. Thank you.
Okay, we have a new member join. I want to say hi. Actually, I'm not sure how to pronounce your name. Muyava, is that right? You are the one actually made the big contribution for global anonymity. Do you want to come online to say hi for just a quick introduction? We'd love to.
Eileen, I'm glad to be able to make it because I'm in UK time zone, so I get the time mixed up sometimes. I'm a DevOps engineer. I've been a DevOps engineer for quite a while now, and I'm just happy about contributing to open source and all of that, just to deepen my expertise in Golang as well. And yeah, thank you for the shout out.
All right, welcome. Sorry you joined towards the end, but I'll send out the recording because Daniel actually did an amazing demo of running inference extension, kgateway in EKS. I think it's definitely worthwhile to watch. I do have one question before we wrap up. I know we're a little bit over, but if you guys have any questions, because the community meeting is supposed to be engaging, now is a good time to ask. So Daniel, you showed kgateway implementation for inference extension. Now, now, if I think about the context of Istio ambient, recently I've been exploring using kgateway to do rain limiting, right? To your PR, Maya. It's also about global rate limiting enforcement with kgateway as a waypoint. Can I use kgateway as a waypoint and also gain the inference extension capability through the work you just presented, Daniel?
You know, it's a good question. I don't, not 100% sure where kgateway falls as a waypoint in Istio. What I would say though is if we go back to the getting started guide and for those that maybe joined late here, it's back here. If you actually go down to the deploy inference gateway section, 1 second here.
By the way,
There's-
when you deploy the inference gateway, you have your own type, right?
When I
Your
deployed the gateway, yeah, I named it inference gateway. So let's see here.
And you have your own class, because I know for Istio waypoint, it needs to be like kgateway waypoint class. So maybe it won't work out of the box.
Yeah, so this is the default class that gets created when you install kgateway, right? This is the gateway that I created in, let's see here, right? So we just to walk through this, right?
We can see your screen, by the way, if you are talking.
So let me go back and share. And let me go. All right, I'm back here. So deploy the inference gateway. Right now, you can follow the instructions for GKE, Istio, or kgateway. Lior, he added Istio support. So
the gateway, he added for ingress gateway, not for ambient, just so you know.
okay. So yeah, I mean, I think similar to kgateway, right, where it's like, okay, we have initial support, right? I mean, as of just a couple weeks ago, we got initial support, initial functionality, and I think that's where we're at also with Istio, right? Is okay for ingress. So you have clients or services outside of your mesh and outside of the cluster that want to, want to communicate with model servers running on your mesh. And have this kind of Gen AI aware load balancer, then this is, follow these steps. If you don't have an Istio mesh, you got model servers and you want to leverage inference extension as a Gen AI aware load balancer for your model servers, and you can follow these kgateway steps, right? And again, we're installing the kgateway CRDs, and none of these CRDs here are specific to kgateway for inference extension, right? You install kgateway, you deploy the gateway, and again, this is right here. This is the gateway that the step deploys. You see after you deploy it, you see that it's been accepted, that it has an address assigned. Typically, this is an IP address, but if you're familiar with EKS, these are host names instead, right? And the other key with this is, what gateway class are we going to use? And again,
right,
kgateway creates both of these, right? So Lynn, you mentioned here's the class that you typically see, right?
So basically, when you deploy one gateway resource, you actually lands up with two gateway objects here.
No, these are the gateway classes, and gateway classes are typically installed with the gateway implementation, such as kgateway. So when we go through this step here of deploying the gateway, installing kgateway, kgateway will create these gateway classes
Yes,
if they don't exist. If they
that
don't
makes
exist.
sense. I misunderstood the short name gateway
Right.
class. You see, yes.
Right. And so when I create this gateway named Inference Gateway, one of the things you have to do according to the spec is say, okay, you're going to create this gateway. What gateway class is it part of? So we know which, which gateway API implementation is responsible for managing this gateway, right? Because in this cluster, I could have kgateway and I could have other gateway API implementations. And the gateway class is very similar to storage class and what was there, ingress class as well that was added to the ingress API. So this is very similar in concept as well.
Okay, that makes sense. Yeah, sounds like there's potentially additional work to support it for Istio Ambient for inference extension. Yeah.
It may very well work with the kgateway waypoint. I mean, one of the big problems, or not problems, but challenges, I guess, with Istio's waypoint is that it implements the Z tunnel inside Envoy, essentially. But we don't have that limitation in kgateway. Yeah. We have an external Z tunnel. So it seems plausible that this would implement more easily in kgateway waypoint.
I totally agree. I think it might just be, I doubt it would work out of box, but it might be small tricks because the mismatch of the gateway class, that would be my guess, but I could be totally wrong.
Yeah, there may be tweaks, but I think it's definitely worth trying.
Yeah. All right. Does anyone have any questions before we wrap this up? I think this has been a good discussion going forward for the community meeting. I love us. If you have ideas on how we can be more engaging, do share with me. I love to have a topic expert kind of leading the discussion, or maybe some of our user, Craig or Mojava, if you have, once you have enough hang of kgateway, if you would love to talk about your experience, we would love to hear from you as well. But whenever you feel ready, no pressure for sure. All right, let's go ahead and wrap this call up. Thanks everybody for joining, and thank you, Daniel, for the amazing presentation and demo. Thanks everyone for joining. Bye.
Thanks, bye. Yes.
Thanks.